All right, this is chapter 1-4, angles and their measures, Please hit pause so that you can copy your cuts. All right, to begin with definitions, we're going to start with angles. We have here angle NOP, and all the angle is simply are two rays that share the same initial point, or end point in this case, which is angle, point O. So the two rays that we look at here carefully would be ray ON, and remember the initial point is on the left with the continuous point on the right, and the second ray is OP. Again, O is the initial point, therefore being the first point that I'll list, and then the P, as stated here. So O is the shared initial point. Again, as I stated, N and P. The rays make the sides of an angle. So the two rays that we have are ray OP and ray ON. The vertex is what we call the initial point. So the vertex on this particular angle, angle NOP, is vertex O, as we see here. Okay, there's your vertex O, which is also called point O. Okay, and this angle NOP can be called three different names. It has three different names, same meaning, and we can call it out by three different ways. Number one, we can call it out by its vertex. When I'm talking about this angle, it's here. That is angle O. That's one name that we can give it. We can also call this angle NOP with the 3 points. Notice how O, which is the vertex or the initial point, is in the center of the 3 points that I call it. Let's see. Here we go. There we go. All right. So O is on the is in the center. The third way we can call this is angle PON. Again, that's the third and final way we can call this angle O. So angle O, one name, angle NOP when I'm referencing this angle, or angle PON with the characters looking like such. Some more definitions for you. When I'm looking at this angle AOP, I have 2 points that are in the interior and exterior. The interior point, and keyword in, meaning inside, as an inside, is point J. Point J is in between angle AOB. Therefore, again, J is the interior point. The exterior point is point V. It is on the outside of the angle AOB, or we can call this angle BOA. And the third way we could also call this is angle O. The exterior, as an exit or outside, is point V. Okay? And as we have here listed, point J is the interior point because it lies in between or in the middle of angle AOB, and points B and A lie on that same line here, right in between. J is in between the two rays there. Okay? Next, point V, as I've already stated, is your exterior. It's on the outside of angle AOB, and it is not in between the two rays there, ray AO and ray OB. Okay? Therefore, point V is the exterior point. Naming angles. In this particular angle, I see 4 angles. If we name them, we can name the first one angle TSU, claiming or meaning this angle here, angle TSU. I can also name that angle UST, there. Both of those angle names mean the same thing, and I'm referencing this particular angle. The second angle that I see is angle USV, meaning I'm referencing this angle, angle USV. The other name for that angle is angle VSU. Still referencing the same angle here, however it has 2 names in which you can call it. Finally, I said 4 angles, but actually there are 3 angles, and I see angle TSV, which is the giant angle here. TSV, angle TSV, or we can call that giant angle VST. So that's the third and final way we can call that. We can never, when we have an angle being cut with another ray here, we can never call this angle S. Why can't we? Because if you say angle S, my question to you will be, which angle S are you talking about or referencing? Are you referencing angle TSU when you say angle S? Are you referencing angle USV when you say angle S? Or are you referencing angle TSV? When you have a third ray here, like you do on this particular or these particular angles, you cannot call that angle S any longer. It's too many different angles connected to one another. Okay? And as I stated in this example, you should not name angle S by its singular because it has more than one angle associated with it. Adjacent angles. Adjacent angles are angles who share the same vertex. And the vertex that we're sharing here in this particular case is vertex G. Okay? And the adjacent leg that is shared between the angles is ray GH. This ray right here is your adjacent leg. If we remember what the word adjacent means next to. So GH is going to be the leg for angle EGH, is shared right here. And the ray again, GH, is also used for the angle FGH there. So it's shared or adjacent because it's next to. Okay? Angle addition postulate. This is postulate number 4. As I stated before, postulates and theorems you need to commit to memory. Kind of like segment addition postulate where you take two smaller segments we did before to make one large segment. In this particular case, you can take two small angles and make one giant angle. So in this particular case, we look at the three angles. We have angle TSU, which is the measure of 18 degrees. And that lowercase m means measure. When I write a cursive lowercase m, it means the measure. I want the angle measurement, which in this case is 18 degrees. Lowercase m, measure means 18 degrees. Okay? Now, I have the measure of angle TSU to be 18 degrees. And I also know the measure of angle USV to be 43 degrees. The question is, what is the measure of angle TSV? And I like to trace because sometimes it can get confusing. So angle TSV, that means we want the whole entire angle here. What's the measure of that angle? Well, we can use angle addition postulate by simply, I don't want to scroll the screen too much. Here we go. By simply adding the angles. Because we have 18 degrees for the measure of angle TSU plus the measure of angle USB, which is 43 degrees. When we combine that, we can get the entire measure of the angle, the measure of angle TSV for 61 degrees. Okay? So this is how we will write it if we're writing the angle addition postulate. It will be the measure of TSU, which is that first angle, 18 degrees, plus the measure of that other small angle, which was angle USV, to equal the entire angle TSV. Okay? And we just use substitution where I know the measure of angle TSU. Again, we have 18 degrees, which is listed there. Plus, I substitute the value of the measure of angle USV for the actual value, which is 43 degrees. And I would be able to find the measure of angle TSV. Okay, and again, that's your angle addition postulate. Finally, classifying angles. We have 4 types of angles that we can classify. Angles that are small and are lower than 90 degrees are called acute angles. that means the measure inside here, this angle measure, is going to be below 90 degrees. It could be 89 degrees, it could be 42 degrees. And if you scroll back to the last screen where we looked here, the measure of angle TSU is an acute angle because it's 18 degrees, meaning that it's below 90 degrees. Okay? So one type of angle, if we're classifying it by name, is an acute when that interior angle measure is lower than 90 degrees. If we have an angle that is exactly 90 degrees, we call that a right angle. Okay, and you will see generally that box in the corner to let you know it's 90 degrees. Let me let you know. There will be plenty of times you will see angles that look like this and even straighter. Please do not tell me that this is 90 degrees. If they don't put a box in the corner, you cannot tell me that's 90 degrees. That box must tell you it is in the corner to tell you it's 90 degrees. If it's not there, it could be 89 and 9/10. It could be 89.1 and 1/10. You cannot call that 90 degrees. If it doesn't say it's 90 degrees or they don't put the box, do not tell me that's 90 degrees because it's not. So two angles thus far we've discussed. The acute below 90 degrees. The right angle is exactly 90 degrees. Then we have obtuse when the angle measure is greater than 90 degrees. It might be 95 degrees. It could be 120 degrees. And so on and so forth. Obtuse greater than 90 degrees. And then finally is the straight angle. Straight angle is just that, a straight line, and the measure will equal exactly 180 degrees. Okay, there won't be a symbol for that. They'll just tell you it's a straight line or a straight angle when it's exactly 180 degrees. If they say a line, if they tell you a word or say the word line, you automatically know that it's going to be a straight angle. And this is concluding your 1-4 message.